Hi and welcome to the Naval Tick Tinkerer. The sun is not as great as previous episodes, but that's how it is here in Sweden. And what I'm building here is the electric 3D printed jet outboard motor for my son's jet boat. So let's take a look at it. So here we have it. This is where we left off, and I have been doing one thing I want to show you, and it's a little bit about the process of building one of these things. So in the previous episode, we connected the ESC, which is the motor controller, to the motor, and we have an aluminium 3D printed impeller inside here. And after running it a little bit for a little while, suddenly I could see the shaft become real hot. Might be that I don't have the water cooling to the motor, so maybe it was the heat, but I do think it's friction. And what I have here is a little bit of my own design. This part, the rest here, the pump and everything, that's MJet. So I want to give credit to that guy for designing this awesome thing. And I could see that the shaft became really hot. And if it becomes really hot and you have plastic, that's not a great thing. But before we take a look and kind of take everything apart again and see what went wrong, I just want to highlight a little bit about the process. So in the beginning, I was just printing this one is in PETG. So we can kind of see this part. And you can see that these are really small here. And gradually, I went to the next one and I made some modifications and I made them bigger and then bigger. And now they're really big. And the reason is that it's really hard to screw these on, even with the spacers are 3D printed here, as you can see them. So it just the process of kind of doing these things. It takes time. It's and somebody's having a great time. It takes time. You got to try until you get it right. So now I'm gonna take this apart, and then we're gonna look at what went wrong. Taking it off. So that looks good. Sorry for the noise. And yeah, I'm gonna have to use both hands. Okay, so I just took this one off, and as you can see, in here there's I don't know if you can see it, but there's a screw down there, in there, that this one is kind of hitting. And of course, if that one is going real fast, that could create a lot of friction, but it doesn't really look like it should be an issue. Seems like it kind of pulled it off. So let's continue taking everything apart and see what the hell. I bet there's something in here that... But you can kind of see the ball bearing there. It looks normal. Looks like it goes around. So it moves. It's not like it's stuck or plastic melted or anything, but yeah, I could see that the end motor could become real hot. And I mean, I didn't run it for a long time, but still, yeah, this looks fine. Everything looks fine, which is great. So this shaft was really tricky to get out, but it actually should be, because there's a ball bearing in here and a ball bearing under there, and it should sit as tight as it just possibly can. So I literally have to force with a lot of force it in and force to take it out. But as you can see, I kind of coned this off here to get those two screws or bolts to kind of stick to this one, so that it doesn't kind of try to hold it against something round, but something flat. So what I can see, I don't know if you can see it, but maybe you can now. It's white here. And that means friction against the plastic. And if it has friction against the plastic, no wonder it was damn hot in here. So that could have been the reason. So let's take this one off and take a look at it. And don't you know, there is friction. It's literally just too tight. So it was spinning against this plastic, which is probably, yeah, you can see it kind of melted. It's all like glossy there, and it has this messing I don't know, copper-ish in English, and yeah, so I have to make more distance, and I don't need this big. I could actually make this smaller here, so it's I can see that I have like half a centimeter in there, and I could just make this smaller. So into play with CAD, take it out again, and you can kind of see the yeah, this rubber thing here. So I'm a bit tired. I was out fixing my boat the whole morning, the big boat, sailboat. So I've been working on that to make it ready for the summer with my friends. So this has to be designed, and definitely that friction is no good. Absolutely zero. I really wished I had designed this bigger, because this is real tricky. Maybe I could move this a little bit in. Probably shouldn't though. But the bad thing is I cannot really see what's going on. You can see that kind of, there's small portion. I mean, it's really been, yeah, let's take this off and just take a look at it. And here we can see, yeah, definitely it was running too tight, and at high RPMs it started melting the plastic. So I need to make a spacer there. I feel this one is a little bit underdimensioned. Maybe it should be bigger. And I would like to have more screws in it, like one from the side here. I do have these small ones. I could make a hole and thread it, but yeah, let's run with these for now. What I could do though is to create a better space here on this one, so that there's more vertical angle for that one to bite. You can kind of see it here, that it's been biting in there. So yeah, let's make that a little bit better so that it actually even has even more. So I'm just gonna take a little bit more off to make it more vertical here, so that it really can't push that easy and destroy it. And then 3D print another part. So what I also wanted to show is that now the spacers is just gonna be amazing. Like if I put one like this, this is the new one. Of course it doesn't want to go down first try. This area is what I wanted to have. Like you can literally work with this easy with any tool. Now it has space around it. Lovely. This is going to make everything so much more easy. Cool. Let's go to CAD and 3D print yet one more version of this one. Sorry. Yeah. So let's take some space away. We don't need it this thick. And I would really like to see through what's going on. And I'm about to print this, and as you can see now I have support here. So let's just go layer for layer and just see how it looks. And what you can see is that it's going to be kind of going into the air, so that's support, the green thing. And if I move upwards every time it prints a layer, it's yeah, not great to have that there, but yeah, let's print it out. ABS, here we go. So while that one is printing, let's take a look a little bit at this. As you can see, maybe this white silicone doesn't really stick well to the ABS, and that doesn't really matter, because when there's pressure from all these pulling down, my hope, at least, that's a big hope, is that it's going to be able to kind of isolate it better than just this TPU in itself. So hopefully I will have like lots of barriers here. I don't know if you can see them, but I printed barriers here to make sure that water doesn't get in. Okay, sorry, my neighbor is also working here, but let's sum this up. So I am gonna change so that nothing is going against this one. I don't like this at all. And I ordered silicone hoses and hose clamps. I have ordered bullet connectors for these, so that we can actually have a nice banana connector in here. I think they're called that because that's what I bought. I bought more hose clamps like this, but better ones, stainless. And I've been thinking a little bit what I'm gonna do. And I have seen a lot of videos where some people, they build things and they have this underwater. I mean, the motor underwater won't be great, but it's not a disaster if it would come water in. And this is going to be over the water line. This is going to be under. So at some points, yeah, sure, water can come here, but I don't want, I mean, let's say a hose clamp gets destroyed and so forth. So I was just thinking if I'm going to redesign this a little bit. So I think I'll do like this. I think it will be kind of cool. I'm gonna make a box on top of this, and that box will get water to the ESC, and the lines will go through one box to the next, so it won't be super tight, but yeah, whatever. Now we have a helicopter. Sorry for all this noise. So I'm gonna design so that the ESC is up here, and these 3 cables go down there, but that's it. So the only thing coming there to the here is to cool the motor, which is great. And this one I designed before, so if water hits in here, it goes all the way up and into this box here, and then it will throw out. So these will be directly connected to each other, which will be neat, I think. So that means that the ESC water, if it gets really hot, it will not like affect the motor temperature. Well, I want cold water in here as much as possible, and I want cold water to the ESC. So yeah, I also saw that this is a C-Shark 200 amp, and it's a little bit too high, to be honest. I'm gonna not use 5 input. I'm not gonna use 12. I'm gonna use 10. So 10, I mean, that's 36 volts or 42 at max, and yeah, a little bit under 30 when it's half. So I think I'll go back and do some CAD work. I will print a new part to make sure that the screw doesn't hit here, and then design the box, and I can print that out tonight. And maybe in 2-3 days from Amazon, I have all the new parts and I have the new lid, and then it's time to test it. That'll be cool, won't it? Okay, so before I end this video, I just want to show you a few things. I connected the power cables to my constant DC power source. No, I shouldn't be using that, but yeah, it's been working and it's nothing broke. So if I do forward, you can see the motor spinning. I also connected this servo, so I got a 60 kilo one. So the idea is that I will have a servo here, so the arm goes like this and that one goes like this, to which will be connected somewhere. Yeah, you can imagine something kind of pushing. So how am I going to keep this from not melting if some water comes in? Well, if we look at this C-Shark, we can see that it has silicone everywhere. This is totally waterproof to start with. But then of course we get to servos, and this might be run in salt water. And then we have this RC receiver. And well, I saw this really cool video, and I'm not kidding you. They use this. This is not a commercial for anything. I don't have that many followers. I'm not aiming to be a YouTuber. I just want to share with the community and think it's fun. So this one just sprayed straight into the motor controller. No, sorry, the RC receiver. And you could literally put, they actually do this. They put this straight into the water and keep it below water. Take it up and it just keeps working. Insane. So I'm gonna just push a lot of this straight in there. He didn't even take it apart. He just, pushed it straight in there, and it just works, even when we put it underwater. So this one, which is 60 kilo, well, this one needs a bit more heavy duty apparently, because they put it to salt water. So I'm going to use something called CorrosionX HD, which they also use for their servers. So if they could use it in salt water, I'm going to be able to do it, I guess. This won't be used that much, so yeah, if it breaks, no big loss. I didn't pay a lot for this. I bought it in China, so it was dirt cheap there. So not from China, I actually bought it in China, and I will be traveling there soon again. So yeah, maybe I'll get an 80 kilo. I think that's better. But 60 kilos side force, I mean, it should work. I don't think that'll be an issue. But as you can see, if I now move this one, so just gonna have to figure out how I can stop this from just going 360. I don't want it to go 360. You can also see the voltage drop. So kind of cool. And the way it measures the voltage drop is what I talked about before. This cable that comes from here, from that battery pack, it actually measures the voltage. So yeah, that's needed for the remote control to see it. But that won't really help me, because this receiver can only do, what does it say? It's upside down, but it's, what is it? Let's see. Yeah, input 4 volt to 9 volt DC. So no way I'm gonna put like 36 volts into that one, or even 42. So yeah, and this plastic shit, that will never hold up. I need some metal ones, preferably even stainless steel, because with these forces we're talking about, it's going to be pushing a lot of water to the side. Yeah, we're going to need something in metal. And luckily enough, I just bought myself a CNC. So yay, yet another project. But it's kind of tricky because it needs to bite into that, so I might just buy something. Yeah, if you know how to program one of these hot RCs to kind of not be continuously moving like it does right now, because that would kind of break everything. I need it to be just to one place and stop. Yeah, maybe I should read the user guide. But anyways, I'm gonna open this up from below. I'm gonna put some of this Corrosion X, just fill it up as much as possible. It's really dense. And then use this Corrosion X, the standard one, the red one. So that was like 50 bucks together. I mean, it's worth it. These things cost money, so it didn't cost a lot of money in China, but if I want one more, it's gonna cost me a lot. Maybe I should put some in this one too. I mean, it might fall into the water. Yeah, I think I'll do that. Anyways, thanks for listening into this episode. Sorry for all the noise, but yeah. Anyways, like and subscribe if you like what I'm doing. Give me some comments. I got some great comments last time that helped me out. So cheers. Have a good day.